These are the Algebra 2 notes for linear programming day 2. So for our first problem, we have a shaded in shape, and they're asking us to name each corner point. So just one at a time. Remember, this is your x-axis and your y-axis. And every time we name a point, it's the x, then the y. So I'm going to start with just this one over here. All right, that point looks like it's over 3, up 3. I'm just going to go around. You can do these in any order. That point would be over 9 and up 0. Take a moment and see if you can figure out what the rest of these corner dots are. I'll give you just a second. All right, so this one down here at the bottom right is 4, -5. Then I have 0, -5, -6, 0, and -3, 3. Okay, just one thing to note, that these dots, something like that right there, that's not a corner, it's part of a straight line, so we don't consider it to be a corner. Okay, same thing with any of these over here. Don't count those as corners. They have to actually be where the corner points are. Okay, so for the next part, we are going to then be graphing these and then come up with our own corners. So for example number 1, the objective function c equals 3x minus y. It's going to go in this table right here. We just copied it over. We're going to work on graphing the constraints first. So we're going to graph these on our grid and then come up with our corners. So x greater than or equal to 0 and y greater than or equal to 0. We're not going to worry about the greater than or equal to. We're just going to graph the line and then fill in the shape once we're done. So I'm going to have x equals 0. It's going to be straight up and down. Y equals 0, straight across. Then if you notice, this last one actually needs to be solved. It needs to be put into y equals mx plus b form. I'm going to put my -2x first, and then plus 6. That would be my slope. And then I'm going to graph my y-intercept of 6. I'm going to go from the origin up 6, down 2 and right 1, down 2 and right 1. Continue that pattern. And I can also go up 2 and left 1. So once my shape is drawn, you can see that it makes this triangle in the center that contains all 3 of the lines that I drew. So shade that in a little bit. And then it's going to look just like the problem on the front where we had to, or on the top of the page, where we had to get the corner points. All right. So the corner points for this problem are here, which is 0, 0. Over here, I went 3 over and 0 up. And then this top corner here, I went over 0 and up 6. Then we fill in our table. This first number is going to be our x, second number is going to be our y. So c equals 3 times 0 minus 0. Do whatever math I need to for that. 3 times 0 is 0, minus 0 gets me 0. All right, next one. C equals 3 times 3 minus 0. So each time I'm plugging in the first number and the second number for x and y. All right, 3 times 3 is 9. 9 minus 0 is 9. The 0.06, plug in the 0, plug in the 6. 3 times 0 is 0. 0 minus 6 is negative 6. So these are your answers for each of the x, y values. And then they're going to ask one final question at the end. The maximum is the highest number. So looking at this last column of 0, 9, and negative 6, you just write down your biggest number, 9, and then where that corresponds to. So I have the biggest number at 9, and that happens at 3, 0. So we write down the 0.30. Okay. Let's look at the next one. Remember, you can always pause the video if you need to kind of write some more stuff down. All right, so problem number 2. Remember, this C equals is just going to go into our table over here. And then the constraints are the things that we are going to graph. Notice here now that there are 4 things that we're going to graph, which means we're going to have 4 lines on our grid. The first one, x equals 0, that's going to be a straight up and down line. Same thing with this one, straight up and down, vertical line. Y equals 0 is going to be a horizontal line. So I'm going to graph those first. That's x equals 0. Right here is x equals 5. And then I'm going to draw a cross horizontally for the y equals 0. All right. Then we're going to graph this one here. Y is equal to 2/5 x plus 3. So I'm going to start in my center here, go up 3, put a dot, and then 2/5 means I'll go up 2 and over 5. It'll land me right there. So from this first point, up 2 over 5. We'll do that one more time, up 2 over 5. And I create this line right there. Okay. So you can see we have a shaded area here. It's kind of it's a 4-sided shape. Not quite a rectangle, but it's this area right here. We'll just kind of shade that part in. Then we're going to need to get our corner points. So for our corner points, we are going to have this bottom corner point here. That's my origin, 0, 0. I'm going to go to the one right above it here. That's 0 in the x direction, right and left, and 3 in the y direction, 3 up. This top point over here, counting carefully, 1, 2, 3, 4, 5 over, and 1, 2, 3, 4, 5 up, the 0.55. Then this last one down here, looks like I went over 5, so 5 for the x, and I didn't go up or down at all, so that would give me the ordered pair 5, 0. So remember, all of these x, y's are your ordered pairs. Then you're going to very carefully plug each one of these in to the x and the y. Plug it in for the x and the y. A lot of these are zeros, so that means they'll cancel out and we don't need them here. So this first one, 4 times 0 and 3 times 0, those are all zeros, so I get a 0. Here, 4 times 0 is nothing. And then negative 3 times 3, negative 9. All right, the next one I have numbers on both. So 4 times 5 is 20. 3 times 5, 15. Subtract those to make 5. Here, 3 times 0, that gets me 0. So I just have the 4 times the 5 to make 20. The last question asks, what is my maximum value? So looking at your C's here, what is the biggest number that you see? 20. And what ordered pair does that correspond with? 5, 0. Okay. On example number 3, notice your table over here on the right side is blank. So the first thing we're going to do is fill that out. So this first column is always the X and the Y. The middle column is whatever your objective function is. That's the one that's going to go into the table. Over here. So I'm going to copy down C equals X plus Y. And at the very end will be my answer for C. All right, we've got 3 constraints to graph, so 3 lines to graph. Any X by itself is going to be a vertical line. Any Y by itself will be horizontal. And if it has an X and a Y, it's going to be a diagonal line in the form Y equals mx plus b. Notice I have a slightly different grid here as well. Back to a regular graph. Y is 4, will be right across here, go through the y-axis at 4. This last one, you need to solve for y. So we'll subtract the x. Y greater than or equal to negative x minus 1. Now, since I'm going to be graphing it, I'm going to go ahead and put a 1 over 1, so I have a number for my slope. We'll graph this very last line. From the center, go down 1, and then down 1 and right 1. Up 1 and left 1 to get the other part of the line. And you want to go make sure you go far enough so that your line crosses the other lines that you've drawn. That way you can find your corner points. Okay, if there's 3 constraints, if you graphed 3 lines, it means you're looking for the 3-sided shape. So our triangle here right in the center. This little piece right here is going to be where we're going to find our corners from. So fill that in with your pencil. Then you can work on getting the corners. So notice here 2 of the corners are where the dots are located. And this third corner doesn't actually have a dot there, but that doesn't mean it's not a corner. Anytime the 2 lines connect or cross, it means you have a corner point. See if you can name those 3 points and put them in the XY column of our table. All right, so those should be your 3 points. And then our objective function in the middle. This one looks pretty easy to plug in. You just take the x plus the y. x plus y, and x plus y. -1, +4, and -1. So we actually have two answers that are the same. That's okay. Looking at your C part of your column, you're looking for the largest number. That will be 4. And then you come over here to see where that happens. That would be at the point 0, 4.